Hello everybody! Today we are going to talk about variables in the C++ language. Let's note that in comments / and now variables. Okay. Let's start this topic not from what is variable, but why do we need variables. For example, I want to send something to the console output. Let's write cout 2 angle brackets 4 semicolons. So it means that I want to send a number 4 to the console output. But hey, what if I wanted to store this number somewhere? Because I would like to make some operations on that number or even change it a bit. Look, right now we have the number 4 here, right? And after that instruction is invoked, we can't do anything with that number anymore. So we can't do anything here with that number here. So this number disappears. We don't have any reference to that number. That's why we need variables. Variable, as the name suggests, is something that is able to vary. So it means that it is changeable. It can be changed anytime you want. So variables are some kind of containers that can store values like numbers. Imagine that these bins, containers here, are our variables. Each of them has different label name, right? A, B, and C. As you can see, each of that container is also a bit different. They have different shapes. It means that containers, variables, can store different values, different type of values. Now we have discovered a new thing, the type of variable. The type describes what can we put into our containers variables. Okay. Let's create variable in our program. Let's name it A. We have got only label now, name of our container variable. We have to also describe what can we put into our container variable. So we have to declare the type of variable. Let's start from the int, which stands for integer. Integer are numbers that have no fractional part and they can be negative. So now we can assign to our variable only integer. By assign, I'm meaning putting something into that variable, right? But let's stop for a second and think about memory in our PC. Is it unlimited? No. It is limited by our hardware because we can only assign subset of integer numbers. In our situation, we are allowed to assign to our variable named A numbers that range from -2 billions to about +2 billions. Let's do that. A equals, for example, 4. The equal sign allows us to assign values to our variables. The process of assigning value to variable is called initialization. Okay. I can do that process of assigning also in one line. I could write something like that. I will comment that thing here. Okay. But let's assume I want to assign variable to variable A something like, for example, I can't do it because this value is greater than 2 billions, okay? And it's really good idea that we can do it because we would take too much memory in our PC. We don't need that number for all the situations, right? Okay. Now I will say something very important. When you look at any book, what is the easiest way to find something inside? If I give you, for example, one section of book, or even only one word, and I will tell you to find this section inside a book that has 1000 pages, I'm sure it will take you a very long time to complete the task, right? What about the same situation, but now I'm giving you the number of page? You will find it probably almost instantly, right? In programming world, that situation is almost the same. The section word in our program is called label or name of variable, right? The page number is called address. Address. Okay. So by using variable address, we can get to values faster. But this is a bit advanced topic and it is connected with pointers. We'll explain it later very precisely. But now I want you to know how to get address of variable. In order to do it, we have to write something like ampersand. It's ampersand. And let's do it in another line. Ampersand, and now the name of variable. Okay. Let's send that things to the console output. Let's do something like that now. Cout and cout ampersand a. Now let's build it. And as we can see, we have everything in one line. So we will add here something like and all. L stands here for line, so that thing here is indicating the end of line and it's adding the enter at the end, right? So now when I build it, as you can see, we have in 2 lines 4. In the first line there is 4, right? And in the second line we have the address of that 4. So we have the address of the variable. When we write something like a, we are declaring variable. Declaring means that we are informing compiler that there will be somewhere in our program something named in our situation a. When we write something like int a, in the C++ language, we are also defining variable. Defining means declaring, and in addition to this, we are also reserving, allocating space in memory. In our situation, we are allocating space for the variable that is integer, right? Int allocates 4 bytes of memory. 1 byte is 8 bits. So we are allocating 32 of bits in PCs and memory. Bits are zeros or one signs. So we are allocating in one sequence somewhere in our memory 32 places that can be filled with 0 or 1s. As I said in the first lesson, that sequence of 0 and 1s can be translated to our language, or our language can be translated to that sequence, right? And as I said earlier, variable values can be changed anytime. In the second lesson, I was talking a lot about that compiler is reading everything from the top to the bottom, right? So if I write something like that, and I will copy that thing, what will our compiler do now? Let's start from the beginning, because our compiler is doing it that way. So our compiler is including the IOStream library. It will use the std namespace, and then it will invoke the main function. In that line, int a equals 4, our compiler will be informed about existence of variable named a. It will also allocate somewhere 4 bytes of memory, and because of initialization, that equal sign, right? It will change sequence of 0 and 1s to represent number 4 in our PC language, right? After compiler will print to the console output value and address of our variable here. Here, a equals 10, our compiler will change value of variable named a. So it will change a bit that sequence of 0 and 1s. But it won't change the address of variable, of course, right? And let's compile it. As we can see, the number has changed, but the address is still the same. Okay, let's study how we should name variables now. Let's do it in comment. And the first thing is that we can't have two variables that have the same name. Variables can't have the same name. So if I want to declare two variables, I have to have different names, right? That way we can run our program, but we can do something like that. Error. Redeclaration of int a, right? We can do something like that. We can start the name of variable from the number, but we can use numbers in other places. So variables can't start from the number. Let's check it out. I try to create int, and now I do something like, for example, that, right? I'm trying to build it, and I can't do it, but I can do it that way. Easy. Okay. We can't use spaces, but we can use underscores. So we can't use spaces. I can't do something like int, and now I will do something like prime number. I can't do something like that. Okay. But we can use, of course, the underscores, so I can do it that way. Prime number. That's all right. We can execute our program. When we declare variables, we should try to make them self-descriptive. Self-descriptive means that we should be able to guess by looking at the name of variable what is that variable created for. For example, we can write int prime number, right? Or maybe I can do it even that way, int prime number. I can do it prime nr, and I can do it also that way, I prime number. the I prefix here, let us guess by just looking at the name that the type of variables is integer, right? Because I int, right? And this notation, that one here, is called, I will tab it, Hungarian notation. You can type it in Google and you can read about other types. Okay, so let's know that our variables should be self-descriptive. And we can't use special characters, keywords. Let's see what we can do. For example, I can do something like int using, right? Because it's a keyword. I can do that way. It's not working. I can't use the special character like hash. It's not working. Okay. So let's know that variables can't have special characters, keywords. Can't be constructed, może, maybe. Constructed of special characters, keywords. Okay. And variables should be nouns. They shouldn't be adjectives or other things like that. They should be just nouns. Okay? Okay, that's all. In the next lesson we'll discover more types of variables, and thank you for everyone. Hello everybody, today we are going to talk about more types of variables in the C++ language. This is quite logical that there are more types. Right now we only know how to create variables that can store integer numbers. But we also need to know how to store real numbers, characters, sequence of characters. Before we start, let's remind about how to define variables. And let's talk about one problem that might happen when we use variables. If we want to define variable, we have to write what? Type of variable, and then name of variable, and then semicolon. We can also define in one line more than one variable. In order to do it, we should write something like that. Name of variable 1, name of variable 2, name of variable 3, and we could just continue that. Let's check it out if it's working. Int A, B, and C. Build and run. As you can see, our program is working well. We can also assign one of that variable in the same line. For example, I will assign that one, and I will assign that one. Okay. And let's build it. And it's working well. But let's see what values are stored in that variables right now. Cout A and line. And now let's just do that thing to the B and C. Okay, and now let's compile it. As you can see here, variable named A and C has got value that we assign, right? 40 and 20. But why variable B has a weird number here? If you compile that program on your computer, you might have even different number there. And why is it happening? It's because we haven't assigned any value to the variable named B. But this might be still a bit confusing. As I said in the previous lesson, every variable has got something like address. So let's send addresses of variables to the console output. So let's do something like that. Now let's do that way. Let's compile it. VNC, sorry. Okay. As you can see, the address is some weird numbers connected with some letters, right? Like the F, right? And the notation is called hexadecimal code. We don't need to understand it right now, but we should notice one thing. Each of that address is different, right? Here I have 44, 43, and C. So they differ from each other. And as I said in the previous lesson, when we define variable, so when we write something like int a, right, we are then allocating, reserving memory in the same time. It also means that we are allocating address for our variable, but allocating doesn't mean clearing the value that is under that address. Allocating means that we just want to reserve that space for other value. Okay? So if we write, for example, just int b, we are just allocating memory that already might have something assigned. But how is it possible? Still, how? Any programs that are running on our computer could use that space before for a special reason, for example, to store actual year. And when we stop using program that stored, for example, the actual year, the space in memory is again free. It can be then again allocated by other programs like the one that we have just written, but the value is still in there. The value under that address is not being removed. That's why under variable named b, we have some random value. So to avoid complications before using any variable, we should assign default values or just anything, right? And now we are sure what value is under the variable named b. Now we are sure that it will be 0, not some random number. Okay. And let's start from other integer type. Let's learn new variable types. Right now we can store in int, that one, numbers from about -2 billions to about +2 billions, right? But in the same time, we have to allocate 4 bytes of memory. As you can probably guess, you don't need so large numbers in every situation. And if we don't need large numbers and we want to save memory, we can use, for example, something like that. Short integer, and let's name it T1. That type let us assign values that range from -32,768 to +32,767. And so now we can assign smaller values, but we need only 2 bytes of memory. So let's note that 2 bytes. And we don't need to write int when we define short integers. We can do it that way, like now, or we can just remove the int, and it's still the short integer. Let's assign some value to that guy, for example 5, and let's send it to the console output. As you can see, it's working fine. Here we have 5. Okay. Let's study something new now. What if I wanted to use real numbers, numbers at a fractional part? Now when I write something like, for example, that, and I compile it, as you can see, you are losing the value after the point, right? We lose that 6. We have only 5 on the console output. The type that can store real numbers are called in programming floating point numbers. There are two types, two of that types. Float, let's say something to that guy, and double. And let's set it to the console output. And let's compile it. As you can see, now we are not losing the part after that. And now what's the difference between float and double? Float allocates 4 bytes of memory. Double allocates 8 bytes of memory. So it's just doubling the float, right? And to the float variable we can assign numbers that are up to 38 zeros, and here we can assign numbers that are up to 308 zeros, so it's a big difference, right? And in addition to this, double has got greater precision, which means that it can save more digits after the point. So it means that it can save more digits here, right? And because double variable can save more digits after the point, which means we should use doubles when we are calculating something important where the precision is needed, or we need to store very large numbers. Now let's talk about saving characters. Character, char, T4. Char is an abbreviation for character here. Okay. And let's send it to the console output. Let's assign something first. We can't do it that way because the compiler will try to assign here the variable named a. So that guy here. If we want to assign the character a, we should use something like apostrophes. Like that. Now, as you can see, everything is working fine. What if I wanted to store more than one character in the variable? If we want to store sequence of characters that are called strings, we should use string type. So, string, and let's do something like that, for example. And as you can see, text should be inside the quote signs for the sequence of characters. Let's send it to console output. And it's working well. Let's learn how to combine two different strings. So I have, for example, string x, we'll assign value part 1, string y part 2, and now string combined strings equals x plus y. Cout combined strings and line. Let's see. As you can see, part 1 is now combined with part 2 in that variable that is called combined strings. We can add, for example, a space between them now, like that. So to combine two strings, we should just use the plus signs. Right? It's working well. Let's talk about Boolean type now. Boolean. True or false? Well, bool is a type that can store only two values, true or false. Maybe let's send it to the console output and compile it. As you can see, we don't have here something like true. We have 1 here, right? But here is true. Why? Every number that is not 0 is going to be true in the C++ language. 0 is representing false. So false is always 0. Every other number is true. Let's check it out. For example, I will write false. As you can see, we have 0 here. And let's now write something like that. As you can see, we have 1 here. 1 is representing true. 1 is representing true. And let's assign the negative number. As you can see, it's 1. And now 0. And it's 0. Okay, so everything is working well, like I said. Now let's talk about unsigned types of variables. When we look at that guy here, I told you that it can have values from minus 32,768 to 32,767. But there are many situations where we don't need negative numbers. Then we can remove the minus signs, remove it, right? And we are making them unsigned types because it's without that sign. By removing negative part of integer, we are increasing amount of positive numbers by amount of negative numbers. So for unsigned short int, we could assign a value that range from, let's do it, for unsigned short int 0 to 65,535. And that number here is a sum of that numbers here. You can check it out. And let's send it to the console output. Let's create first that way. See out. As you can see, it's working well. Let's talk about that we can also remove that integer here. Unsigned short is unsigned short integer. Alright, it's working well. We can add unsigned to all other types, like float, double, so it's working the same. And let's talk about constant variables now. There might be situations where we're gonna use something in our program many times, and we also want to make it unchangeable by mistake. In order to do it, we have to add before type of a variable a word const, which is abbreviation for constant. So for example, we have string, I will name it name of game, Conqueror of C++, for example, and I don't want this name being changed, so I will add const here. And now let's send it to console output. As you can see, it's working well. And as you have noticed, I'm using uppercase for the name of constant variable. You don't have to do it that way, but it's a good idea, because when your programs gets longer, you will know what is constant variable just by looking at the name of variable, right? It's uppercase, so it's the constant for sure. And we'll know that we can't change the value of this variable from the other part of program. Let's read out, so we'll see if I'm lying or not. Okay, name of game, and now something. Let's build it. And as you can see, we have error here. We can't do it, so I didn't lie. Okay, that's all in this lesson. Thank you very much. Hello everybody, today we are going to talk about how to get something from the console input. So we're gonna learn how to get values from the users. In order to do it, we are going to write something like cin, which is abbreviation for console input. So it's the entrance for the data that will come from our users. When we wanted to put something to the console output, we are writing something like cout, and then we added two angle brackets that were pointing to the console output direction, right? And for example, I will send something like test to the console output. But this time we are taking something from that place, right? From the console input. So we are going to write two angle brackets, but they will point to the right, to something that can store values. So we are going to use now variable name after that two angle brackets. Let's create a variable, for example, int a, and now here I can direct something from the console input to the variable named a. So that value is going to be stored in the variable named a. And maybe let's change that guy here. Variable named a equals, and now let's try to compile it. As you can see, now we didn't see that guy here, that's cout. We don't see anything on the console output, and we have got here blinking underscore, which is waiting for us. It is waiting for us to do something, to give something to our variable named a. So I will give it, for example, 10, and now as you can see, variable name a is equal to 10. Now, as you can see, the type of that variable is integer. What will happen if I try to assign not a number, but for example character, for example key? And as you can see, that character got converted to that number, but it also makes an error in our program, and if our program was longer, it would stop. We will learn how to fix situations like that in other lessons, so don't worry. Okay, now let's train maybe a bit, and I write the program that we ask for name and surname, and we will welcome that person in our program. So how to do it? Let's just create string name and surname, and now let's ask a user of our program, enter your name, sin name, and now let's ask him for the surname, enter your surname. Let's do it the clean way. Sin surname, and now let's welcome that guy that visited our program. Welcome name space and surname, and let's see how it works. So as you can see, our program is asking us for our name, so I'll type my name, and now I type my surname, and as you can see, it's greeting me. Welcome, Arek Wodarczyk, and that's working fine. Okay, that's all in the lesson, and thank you very much.